Hi, girls. Let's start with something cool. That is, if it works. So, everything that you saw in this video, including the video itself, was done with the software. And this is exactly what the company that I work for does. We create software to enable any creative, any architect, designer, engineer, game maker, filmmaker, to create, to imagine, design, and create the world around us. So I worked there for the last 15 years. And my title is product manager. What does a product manager in a software company do? I work with a group of really smart developers, coders, just like I see that some of you are already at the level. And we together think of how can we make the world a better place, or how can we create tools that inspire you or that unleash your creativity, etc. So there are software developers, and then there are software designers, and there is a product manager who is kind of the link between that team and customers. So I'm visiting customers, we're talking what are the issues or what would they like to do, and then translate that back to the team that builds the software. But as you can see, I have another title as well, Technology Whisperer. Have you ever heard of that? I invented it. It doesn't exist. And why I did that was because I wanted to find a name for something that I knew that I'm doing good, which is sitting in front of audiences and explaining how the new technologies can help us do something that we can do better, or that we never, ever imagined that we can do. And why did I call it a whisperer? You know, like horse whisperers or animal whisperers. They usually know how to speak a language that otherwise is not there, right? So why do we need technology whispering? Because you might not be aware, because you're already born in the most exciting technological times. We're in the time of Google and Facebook and 3D printers, etc. But when I was your age, we didn't have Google, we didn't have Facebook, we didn't have smartphones, we didn't have tablets, we didn't have 3D printers. Wait, we didn't have computers. Can you imagine that? Can you at all even grasp that? And everything that you're seeing now happened really in the last 10, 15 years. So many people are not comfortable. It's moving very fast. So you need to whisper to explain why are the new ways better. Or many do not know. So yeah, 3D printers, but what do we do with them? So that is where the whispering comes. So did I ever know that I'll be doing this job? Of course not. How can I, when I'm your age, know what will the future bring and what do I want to be? So let me tell you my story. I'll do it very quickly, and then I'll show you some really interesting things that I'm working on now. So this is me when I was a little bit younger than you. What did I want to be? Well, the first thing every girl wants to be is a ballerina, right? I didn't become that. Then I really loved nature. I was all the time out there and wanted to explore everything. And then I was interested in writing and in journalism. And then my parents, actually my grandparent, my granddad, my mom, and my brother were theater and film actors. And they said, oh yeah, I'm going to become an actress. Well, I tried that as well, and it didn't work out either. And then my father is a composer, so at home we had every single instrument. And I tried to learn piano and violin and harmonica, and nothing worked out either. And then I loved animals, and that love is still hurting here. I really want to do something with animals, but in my city where I live, there was no veterinarian school. So that love today I'm still trying to practice by volunteering in Africa in different reserves, but no, I did not become veterinarian. So when time came to decide what will I be, from all of those things, I chose architecture. Now, that had nothing to do with anything I wanted. So why did I decide to become an architect? Well, because my best friend, Tatjana Efremova, her mom was an architect, and when I asked her, hey, what are you going to study? She said architecture, and I said, okay, I'll do that. I had no idea what architecture really is, to be very frank with you. By the way, this is a real project that I, together with my other best friend, Tatjana Dzambazova, we're all Tatjanas, if you can figure it out, we just designed this as a contribution to the Virunga National Park in Congo, where the last mountain gorillas live. And we hope that this building will be built. But really, my story started with, okay, I decided to be an architect. Skopje is the place where I was born, and I was living there for 22 years. And then I moved to Vienna in Austria to become an architect. There I started to love languages because I had to speak German. I already spoke English. Then I started to learn French and Italian and Spanish. And then somehow the path brought me to London, where I actually discovered Autodesk. And I started to love technology, seeing what we all can do with it. And then with Autodesk, I moved to Paris and then to Boston. And now I'm in San Francisco. And with my job, if I put all the dots, where am I traveling, this will be all covered. So there is no recipe on how will you arrive to the day where you will be doing what you want to do. My personal recipe to you will be really just a couple of things. Number one, always follow your passion and your heart, against all odds. Don't be lazy, be curious, look around, keep your eyes open, open every door. You live in the most interesting of times. You can do things that we never, ever ourselves could do. And always question. Don't accept a no. Question, why are certain things done that way? Because you will see there are always better ways to do it. So let me guide you a little bit through my whispering. Let's say you're talented, you're creative, you want to design things. Where do you start? Well, you start with sketching that we always did. Today you can sketch also even on the tablets with your finger or with a pencil. Or you can start sketching in 3D. There is a program that we make, Tinkercad, which is really, really super easy to use. You just play, push and pull, change colors. In this case, somebody is making a lamp. And the software will help you express your ideas, express your creativity. So here we just drew a rectangle, extruded it, then used some helper tools to make this rectangle empty and add some shapes. And now we're going to copy 4 times this shape to build a lamp around it. Just follow how simple and easy this is. It builds upon all the knowledge that you know from 2D, or if you do a little bit of photoshopping or a little bit of, it's not complicated. And then I will speed up this. What's the idea with this? Well, you can show it to your friends. You can start making it real. You can 3D print it. Or you can export it from Tinkercad into Minecraft. So all of a sudden, you have something that you designed that will be either made real or that will take part in a game as your personal designed asset, right? And due to time, I will not now cover everything that is in this video, but if you're into games, you understand this all too well. And many kids have started to design lots of interesting things. So somebody's trying to replicate a famous architectural building, or you're designing some modern things, or you invent something, or different vehicles, etc. This is more if you're on the engineering making side of things. What if you're more interested in making characters for games or something more organic and fluid? So there is another tool called Mesh Mixer. Here you can start inventing characters. You can play with duplication and whoop. This is done stretching, and then you can also make these assets either used somewhere else digitally, or you can 3D print them. You can make your own jewelry, you can make your own characters, etc. And if all of that interests you, in the next stage, when you're a little bit grown up, you will start using some of the more serious tools where you're designing really things that can be made, like this super modern watch or a guitar. This is Autodesk Fusion. This is a tool for your generation. You can start changing and editing and creating variations and really create beautiful, beautiful designs without the super high-end knowledge of an engineer. Now, these are the ways we were designing things until now. You basically tell the computer by drawing and extruding and revolving how you basically create shapes. But there is a new way to design, and we're just on the edge of that, where, let's say, you have this bicycle, and what's the problem with the bicycle? The problem is when it's heavy, because you have to pull it up and bring it the stairs and the falls, etc. So now we're working on tools where instead of drawing in the computer, you tell the computer, well, I designed this bike, but I want it to be light. And all of a sudden, the computer program starts creating lattice structures and really generatively creating the structure of the bike frame, for example, to make it light. It's still sturdy, it's still safe, but it will make it light. This is what we call generatively or computationally generated tools, or goal-driven design, and that's coming your way. But in the last 2 years, I was not so much working on design. I was working on something else, and I'll run another video to show you actually what am I working on now. I think that the divide between what's analog and what's digital is starting to merge. Our physical world is so unimaginably rich in texture and in depth, but until very recently, our digital experiences, for the most part, have been limited to flat, 2D impressions of reality. Today, innovative technologies like 3D printing, WebGL, virtual reality, and augmented reality are all redefining the ways we can experience and recreate the world around us. So what do all of these revolutionary technologies have in common? They all require high-quality 3D digital models. What does it take to make a 3D digital model? You can create a model from scratch, geometrically constructing it by extruding and revolving with NURBS, meshes, splines, and solids. It's a laborious process requiring complex software and high-end knowledge. Alternatively, you can capture the analog world as it exists. This can be achieved with specialized 3D scanners, but this type of hardware is prohibitively expensive and also requires immense technical expertise. Every day, technology is becoming more accessible and easier to use, but the difficulty of generating high-quality 3D assets has kept this trend out of the world of 3D. Until now. A new process called photogrammetry utilizes state-of-the-art algorithms to convert regular 2D photos directly into 3D data. With smart sensors that are now ubiquitous and new software that is exceptionally easy to use, anyone with access to a modern smartphone or a camera can now capture and create a high-quality, ready-to-use 3D digital model. What stories can be told when we can all digitize the world around us? For artists, being able to easily capture, modify, and recreate physical assets opens up a universe of possibilities. When we can sculpt any object, environment, or living thing, the entire world becomes clay in our hands. For marine biologists, it's helping them better understand the world's ever-changing oceans. For the first time ever, using photogrammetry, scientists can measure coral reef systems with astonishing accuracy.
Not only does this enable us to document the state of existing corals, but with repeated scanning, we can actually observe ecological changes as they happen over time. The Buddhas of Bamiyan in Afghanistan were glorious statues carved into a massive cliff over 1,000 years ago. In 2001, they were destroyed forever when they were dynamited in an act of religious extremism. Like so many times in our history, an invaluable piece of human heritage had been lost. Except this time, we decided to search for the lost statues in a place that previously nobody would have ever thought to look: the web. Between Facebook, Flickr, and Google Images, there are thousands of photos of the Bamiyan Buddhas taken by tourists through the decades and from almost every possible angle. Using photogrammetry and hundreds of these crowdsourced images, a team was able to digitally reconstruct the Bamiyan Buddhas in a gloriously detailed 3D replica, one which now celebrates the story of humanity, of all of us together, preserving a vital legacy for future generations. In the near future, we will be able to digitize our entire planet as it exists in every moment. This four-dimensional impression of our world will enable future generations to literally scroll back and see what was really going on in this particular part of the world at that time. We'll digitize ourselves as well, giving our great-great-grandchildren the chance to see us the way we were when we were their age. By being able to better document our achievements, as well as our mistakes, we will help new generations build a future for themselves that we can't even imagine. Some stories are simply too big to be told by one person or one group of people. From passive listeners to active participants, we all have the power to take initiative in this frontier of democratized capture and creation. We're able to connect dots differently, to find deeper meanings in the patterns that emerge, and consequently, we're able to begin asking better questions. These new stories can be experienced differently, in all parallel ways, across time, across geography, across cultures, and most importantly, these stories will mean so much more to us because we were part of their creation in the first place.
So yes, we live in yet another interesting technological innovation time, which is the sensors. So our world is physical, it's analog. How do you put it inside the computer so that you can do something with it, about it, etc.? And as I said, they're laser scanners, but today we can actually just simply take photos, take photo of your head, take photo of some artwork, of some sculpture that you made yourself, or as you can see, what scientists are doing, and just take a bunch of photos, and it's as simple as this. You open a software, you load the photos. In this case, these are photos of a horse sculpture that I captured. And you load the photos in a software, you give it a name, and the software returns a 3D model that you can change, a 3D model that you can print, without any sculpting, without anything into it. So with all of these sensors and smart technology, some smart software, we can now really blur the line between the real world. Here was the real horse sculpture, then I made it digital, and then I returned it back into the real world. And that is what the software that I'm currently working on actually does. Oh. This is, okay. So, let me tell you a couple of stories what customers do with this. So the first one, there's a little problem with the PowerPoint. Okay, hopefully this will work out. Well, the previous picture that didn't show up is a picture of the raven, the common raven, the most intelligent bird on the planet. And the raven lately is having a lot of fun. He's killing the desert tortoises. And these are pictures that are usual now in the California desert. There are thousands and thousands of carcasses of tortoises. And unfortunately to us, we are down to the last generation of tortoises. If we don't do something about this, the ravens will eat them all. And why is this happening? Well, the ravens are now 50 times more than they used to be. And why? Because we have garbage everywhere, the population exploded, and now the balance between the numbers of tortoises and numbers of ravens is disrupted, and they're dying out. So two very smart people, one scientist, Dr. Bill Bowman and Tim Schultz, decided to make an end to this and to use technology to solve the problem. So they said, we'll make fake techno tortoises, and we'll put all of these fake tortoises in the desert, and we'll teach the raven to not kill them. Well, how will we do that? Capture tortoises with photos, create 3D printouts. You can see one of them on the table. And then with those 3D printouts, we can actually, in the future, put pressure sensor on top of the tortoise, and when the raven attacks, it sprays a little pepper spray. It's not dangerous for the raven, but he doesn't like it. And after 3-4 times, he will say, man, this stinks, I'm not going for that anymore. And hopefully, joke by side, hopefully you can really teach the raven not to do that. By the way, which of the tortoises is real? Everybody shows like this. It's very difficult to tell, right? And 3D printing really does this. From capture to print, you really do this. Couple of other stories. This is a friend of mine, Cosma Venman. I met him at a 3D print show, and he was standing next to a big horse sculpture. I said, oh my God, this is so beautiful. How did you do that? He said, well, I used the MakerBot, and I took photos from a horse, and then I printed it. I said, wait a second. MakerBot prints little things, and usually white, and this was this big. He said, well, yes, I do the same, but I split the horse in many parts, print them individually, then put them together, and then paint them to make them look good. And this is what he started to do a lot. He takes a bunch of pictures of beautiful art pieces, and then he digitizes them, and then make them look real. He prints them, but then he makes them look like gold, makes them look like bronze, makes them look like bone, etc. So by now, he has a beautiful collection that he both has produced physically, but most importantly, he's giving this to the world for free. You can download any of these things that he did, and it's unbelievable how many people then used the models that he created to do something else. Somebody was questioning, well, Venus de Milo is kind of having chopped off hands, but what was she doing with her arms, you know? And then they found some old drawings, so then they replicated, they put back the arms, and now it seems like she's spinning a thread. And these are just some other projects that Cosmo shared with me of people using his freely shared 3D models that he digitized to do some new type of art, to do education, etc. So it's really, really interesting. Then this is another friend of mine, Sly Lee. He has a company called The Hydras. He's a marine biologist. He learned about this technique, and he said, I'm setting shop under the water, in the ocean. And he started snorkeling, actually diving, and started taking pictures of corals. Why? He wanted to see what is the state of the corals, and he thought, if I dive today, and then I go again 3 months later, and create digital models, and then I compare them, I can see if the corals were shrinking or growing, and then we will learn if our ocean is doing well or not. And he is the first in the world to do this, and it's really inspiring. He's very young and already using technology to make some great, great ideas happen. So here are some of the corals that he has captured. Look how beautiful this is. You can see it almost as if it's real. Obviously, you can 3D print it. And he also shares the corals for your enjoyment on his website. And then there are many, many other stories. The famous Leakey family in Kenya is uncovering the fossils of the first humans, the first tools, the first animals. And they have thousands of these fossils, but unfortunately they're in the Museum of Nairobi. None of us goes there that often. And they really wanted to put this online and to make them accessible to everybody. And that's exactly what they did. They started digitizing these fossils to put them online so that you at school, instead of learning from boring books or from, just websites that have just an image and the text. You can now go on the website. This is africanfossils.org. And you can start looking at the skulls of the first people. Some of them are small. You can see them on the table. Some of them are bigger. The brain was bigger. The brain was smaller. You can compare different ages, the Neanderthal with the one that was living in Africa, etc. So this is this brave new world. And Louise Leakey, who is the third generation of this family, is not only making this available, but she's also allowing you to download the 3D models so that you can then make 3D printouts yourself at school or at home and learn from that. This is another story. There is a museum in Sweden that has a big collection of Egyptian artifacts, and they wanted to use technology to make the in-museum experience a little bit more interesting. So they called a couple of technologists and said, here you go, this is the body of a Prince Nesfayu, some Egyptian prince. So they said, what are we going to do with this? So we took his mummified body and put it in an MRI. This is usually a machine that you go and something hurts you, so the doctor has to see if you broke your knee, etc. So we captured with MRI the mummified body, and the rest we just did photos. So basically, we generated 3D digital models of the skeleton, of the mummified body, of the cartonnage, and then of the two sarcophagi. We ended up with a 3D digital replica of the mummy, of the mummified body. So what did we do with this? Well, another technology group who is specializing in making these digital tablets put the mummy on it, and now you can unwrap the mummy digitally. You can explore it in detail. You can slice through it. You can read the hieroglyphs. You can really come close to it. Because when you go to the museum, the mummy is behind the glass, and you can just go through the glass. You cannot really touch it. You cannot do anything. This is what we say the end of no touch in the museums. You cannot touch, but you're touching digitally. And because there were 3D models, we can obviously print the sarcophagus and hold them in our hands. One thing that was super interesting is when we made the CAT scan, the MRI scan of the body, we found 120 little amulets hidden under the wrappings of the mummy. Usually they were hiding jewelry and stuff, so when they go in the next life, they have jewelry with them, right? Well, without unwrapping the mummy, just because we digitized it, we could 3D print them, and then we were wearing the same amulets that the pharaohs and the priests in Egypt were wearing. And this is at the beginning, at the opening of the exhibition. You guys have grown up with this technology, so for you, there is no need to explain. You're starting to play with these artifacts and really learn. Another way to use the same technology is very different. Creativity. There are many artists who like using their hands. So, great, I'm now making this clay sculpture, but how do I put it in the computer? Again, the same method. This guy is specializing in making characters for film and game. So he's using his hands, and at some point, when he has the basic model, he starts to take pictures, just like I've been explaining to you for everything else, and then he gets that model digitized, so then he goes in other software and starts to develop further that clay model into something that starts to look more and more scary and more like a real creature, until finally he arrives to this little creature that he then can use in a film or game, or he can 3D print as a mask in rubber or as a sculpture, etc. So you see the line is really blurring between what's digital and what's analog. This is a little figurine that was on a colleague of mine computer's desk. He just digitized it, and I'll show you at the end what he made Superman do, something very embarrassing. And to finish with the Smithsonian, for those of you who have never been, it's the biggest collection of museums in the world. They have 137 million objects from our past. And they said, how will we show the whole world what we have? Because if you go to museums, you only see 2%. They don't have enough building space to put everything that they have. So together, we built a project called Smithsonian X3D. You can also find it online and play with it, where we digitized many different objects and put them online so that you can start seeing how museums of the future would look like. And this was a beautiful story. This is a real cosmic Buddha, and the curator had it in front of him, but he could not see the relief of the Buddha because it was very shallow. When we showed him that because it's digital, now we can deepen the relief and really read it, he was totally solved. So basically, you have now curators being able to tell stories about our past in your language, in the 21st century language, online, with video, audio, text, 3D models that you can explore on your own, not just sit and watch videos or not just read. And the last use of this technology, which is again something completely different, is a company called Unique. And they say, we are all unique. Nobody is the same as anybody else. So focusing on 5 million amputees in the world who are wearing these really ugly prosthetics, and some people are really mean, they laugh about it, and kids sometimes can be really tough, they laugh about it. So they said, why don't we use this capture technology, capture the healthy leg, mirror it, and then around it design a custom prosthetic cover that will not only be for the very exact shape of the leg, but also for the taste of the amputees. And they're making these really cool looking covers. So we have pictures and pictures of fashion models who have amputated leg, from lots of war veterans, etc., who are now wearing this. This is what I love about technology. You see, it was one and the same technology, one and the same software, and how many different types of usages there are. And that's the interesting thing. Technology, guys, is just a tool. It will not make you smarter, it will not make you more creative, but it will allow you to make things that you know how to do. And if you're a good person, you can do great stuff with it. If you're a bad person, yeah, you can do damage with it as well. It's just a tool. The humanity will only go forward still based on the same principles that are not covered with technology, which is be a decent person, have ethical and moral values, and make the world a better place. So this concept we call rip, fix, burn, just like in music. You rip it, you mix it, fix it, and then you reburn it. Now, instead of on a CD, we reburn it in 3D printing in the real world. Or rip, fix, learn. Rip the reality, mix it with other knowledge, and then teach with it, learn with it. I have much more to show you, but I think that I'm out of time, unless somebody says it's okay. And I hope that I could give you just a little glimpse in the world that I'm in, and don't let anybody tell you that it's a man's world. That's an old thing. We girls are multitaskers, and in this world of software and hardware and global economy and everything, multitaskers and big thinkers are important. So be confident. You can win the boys. Thank you.
Thank you so much. That was amazing. And I'm sure a lot of these amazing women here have some questions for you. Do you have some questions to ask Tatjana? She just shared a lot of really great stories and information with you. Anything you're interested in finding out more about?
Yes.
Just.
Sorry, we have to put the microphone.
Oh, what did he make the Superman do?
Oh, yeah. Man, I like her. She does not forget. Okay. It's really embarrassing. Let me just get out of the PowerPoint. Seriously? But the idea of that is to show you, you can make a figurine out of clay yourself. You can design something, then you can digitize it, and not only see it digitized and print it static, you can start making it play ballet. By the way, I brought some of these 3D prints and cardboard replicas. The cardboard replicas are done with a software called 123D Make, and you definitely should check it out. And the rest is usually 3D prints, but look at the tortoise there. It's unbelievable. It doesn't look like it's fake. Yes?
Are you gonna, are you gonna rebuild the Buddha thing with the photos?
Yeah, no.
No?
So, but I mean, that is very controversial. When you have something beautiful and old, sometimes the hole there will tell more than a new built artifact, because the beauty of that was that it was built in times where technology was not there to go with a robot and carve on the cliff. So it's very important to have a reminder of sometimes the things that we do wrong so that we can do them better. We can reprint it in 3D print. We also, there was another scientist artist who actually did projections of the old Buddha with projectors there on the stone. But I think it is important not to rebuild in the 21st century something that was done centuries and centuries ago, but to also remind ourselves not to do that anymore. And you've heard lately there is a lot of that happening around the world. Yes?
I actually don't have it. Okay.
She changed her mind. Yes?
Wait, what were the softwares you named? Like for like building, you were like showing the softwares?
Yes.
Can you like name like the first one you showed us?
Yes, and I will actually send, I'll send the museum a list of the software that I think you definitely should look at. The first one I showed you was a Tinkercad. And that one is if you want to build something and print it and make it real and invention and something like that. The second one is Mesh Mixer. That one is super cool because that makes you make crazy things. The third one, you're a little bit too young for that, I think, but that is the future. It's called fusion, and it's fusing many different things. In software today, you don't only design, but today you can simulate it. How will it behave? How will the car behave if there is a strong wind? Or how will the building behave if there is an earthquake? And also you can analyze depending on different materials, etc. And then you can CAM it, what we call computer additive manufacturing. You can actually produce it with computer numerically controlled machines, which is CNC machines, be it laser cutters, 3D printers, water jets, whatever. So those were the three software at the beginning, and the software that I'm working on is called Memento. Now, there is a mobile version of that. It's called 123D Catch. And you capture with that, and it shows the 3D model. And a little bit more professional version is the Memento one that I showed. It's super easy to use as well. All of these softwares are free for you guys. You probably know, but every school, every student, we give any type of software for free. So just go and grab it and play with it. So you might become future customers of Autodesk, right? You might become designers and creatives, or you might work with us, become coders, and then design the software that will let other people do what I was showing you.
Great. Any more questions over here? So many cool things. Any of our staff and volunteers have questions today?
I have a question.
Okay.
Yes.
So a project like the mummy,
Yes.
how long does it take to, once we have the
3D, yes.
Yeah, or the X-ray, and after how much time did it take to actually?
Yes, that one was a little bit more specific because it was put on a table. The actual capture, we went in Sweden in the museum, we were stuck in the cellar because that is where they allowed us to touch the mummies. So it took us about 6 hours to put all the lights together and to take the pictures. The software makes the 3D model really quickly. It won't take more than a couple of hours automatically. You're not doing anything, you're just uploading the photos and you wait. It's happening on the cloud because we're putting really strong machines that have the algorithms on the cloud so that you don't have to have a big machine. And then you receive an email, your mummy is ready, and you open it. But then that particular mummy was prepared, which what we call volumetric rendering, to be put on a table so that it's combined the outer shape with the inside that we got from the MRI so that you can then slice through, etc. Otherwise, everything else that you just capture with photos will not have the inside. If you capture photos of me, you will get my skin, but of course not my organs, right? For that, we have to do the magnetic resonance machines. But hopefully, those will become also cheaper and more accessible in the future so we can really capture the inside and the outside together. But you should definitely try it. Try 123D Catch on your phone so you can install it, and try Memento if you want to also clean it up and print it, etc. But all of the tools that I told you, I will send you hyperlinks so you can start playing with them.
All right, we've got a question right here at the back.
Yes.
Hey, so did you know how to code at all before you got the job right now, or were you a programmer before?
Oh, now you killed me. I thought I'll go away without that question. I never learned how to code. I learned 8 languages, but none of them is a programming language. And I now kind of regret it because you guys, if I would do one thing today, it would be learn programming language, because knowing how to code is like being God. You can do anything. You can do art, you can help medical, you can create code for buildings, and just anything, anything. There is not one single profession in the world today that does not need coders. So if you ask me, even if you're the most creative and artistic person, learn how to code, because it will help you make crazy, beautiful art and structures, etc. So having said that, I did go to the Hackbright Academy last year, and I did a starting course on Python, just to see if my brain would like it. And oh my God, my brain did like it a lot. It's just that I don't have time, so maybe I'll take a year off and do some Python, but it's super interesting. I really, really liked it. Yeah, so for my job, I do not need coding. And my developers are very happy because they will not want me to code. You know, developers are usually very organized and very chaotic, so it will cause some problems.
That's great. So the coding language that we're using today is also Python.
Awesome.
So the students are getting a little bit of experience
teach me
today with
something?
it. So yeah, maybe you'll come back, and maybe someday some of these students will be helping to
I would
teach you
actually
some
really
new
love to see
languages
you.
in computer science. Yeah. I have a question. So you've been involved with and worked with all these different projects and everything like that. Is there something in the future that you're looking forward to doing? Is there something that you would really love to take on as a new challenge for yourself with all the different technologies that you work with?
I'm very, if I say I'm bipolar, that will not sound very good. But I have really 2 natures. One is this love for technology and art. And in that world, I would like just to continue with my team building tools that empower small players to play the big game. That's how I call it, because if you think about tortoise scientists, those people do not have money. And the fact that we build something that they can actually solve a challenge of a species that can be extinct, that for me is super exciting. So my personal goal in the technology world is to continue helping build products that are easy to use and that are accessible, affordable, and that enable anyone to do some good stuff. On a personal note, I do want to end up in Africa and work with the extinct species, because I find it absolutely horrifying what's happening with rhinos and elephants and lions. And you girls, if you care, raise your voice. You're the ones who will live in a world without animals if we continue doing what we're doing. So that's my personal one.
Great. Do we have any other questions from our audience here? Any questions about the work that Tatjana's been doing in Africa or anything else? Anyone?
Yes, I had a quick question over here about your work that you were doing in Kenya.
Where?
In Kenya?
Oh, so there is this very famous family called the Leakeys. Richard Leakey is the father of Louis, who is a friend of mine now. His father was one of the biggest fossil hunters or paleontologists. Richard Leakey, additionally to that, almost single-handedly in the 70s stopped elephant poaching because it was very extreme at the time, unfortunately. By doing that, he stopped many people who were getting big bribes to do that, be very upset. So his plane was sabotaged twice and fell, and he lost his legs. But you see, people who care really don't mind going all the way. But his main profession, as of his father and as of his daughter, was to uncover the fossils, the origins of the first human beings, of the first animals, of the first tools. And there is a region around Lake Turkana, I was there last year for the first time, where really some of the oldest human remains have been found. And they continue doing it. I went one day to do that. It was 50 degrees Celsius. I don't know how much is that in Fahrenheit, but it's a really hard work. And they're literally going through sand and finding small bones and then putting them together. And it was amazing how Louise, she would find something, this is a tooth of so and so many years of rhinos or something like that. It's amazing. But they're building this huge collection that is gathering in the Museum of Nairobi. It's a beautiful collection. But because we do not go that often in Kenya, this is why they started digitizing it so that you can have access to it and maybe build love to become a paleontologist, to become a fossil hunter. Louise is a real Indiana Jones in a girl's way, you know. She's flying airplanes and she's swimming in lakes with crocodiles and she's finding all these fossils and teaching all around Kenya with these physical artifacts. But yes, the work of this family has been the one of understanding the origins of us as human beings, with the idea that if we understand where we come from and what changed us through evolution, that maybe we will understand what are we doing today with this planet and be a little bit more careful about it. That is their ultimate goal.
Great. And I think I saw another hand up on the other side. There's another question over there from the students? No? All right. So I know that you've brought some really interesting, I was going to call them artifacts, but I guess they're art pieces, 3D printed.
So you're very welcome to come and touch them. Don't worry, you will not be breaking some of them.
Let's just wait 1 second.
In one part. This one, for example, is one of the corals from Sly. It was printed, but then Cosmo Venman painted it to look really like the colors it was originally in. And yeah, speaking of the Leakeys, this is actually Miv Leakey, and this is one of her daughters. So this is Louise's mother, this is the daughter. While we were scanning fossils, we decided to scan them as well. And here you will find the tortoise. I mean, you guys have to come and see this. This is not real. And it really looks real. So come and touch. You cannot break anything. It's not a problem. Just these two that open.
Okay, be very careful. Make sure you can all get a chance to look.
And I did have a lecture on designing and 3D printing, but maybe another time.
Another time would be amazing. So as the students are taking a look at this, what words of advice would you give these amazing young women as they head off into their futures? Would you have any specific words that you'd like to share?
As I said before, be curious, just like you're now. You want to touch it. You want to understand how it was done. Open new doors. Go in your life with open eyes. And always question, because there are better ways to do things, always.
Amazing. Thank you so much, Tatjana.
You're very welcome.
And students, please join me in giving Tatjana a big round of applause. She's an amazing rock star. Thank you for joining us today.
It holds your